Thank you everyone for joining in this afternoon for another presentation of Major Consulting's educational webinar series. This one's going to be on construction, surface modeling, and site staking. I'm the presenter, well, one of two. My name is Ray Payne, Senior Project Manager here for the Survey and Geospatial Services. The other gentleman is Brian Keever. He's a licensed surveyor, also Senior Project Manager with the Survey and Geospatial Services. Thank you, Brian. I'll go over the agenda for the remainder of the presentation. We're going to go over the latest techniques used for civil construction, machine grade control guidance, surface modeling, site staking, cut fill sheets, and volume reports. Sorry about that. Get carried away there. The main reasons for machine grade control. I'll give you a brief description here. In the past, most civil site construction projects would have been constructed by using a grid pattern of survey stakes set by the engineers or surveyors for the contractor to use for the earth moving operations. These stakes would have been set on a pattern of 50-foot or 100-foot grid for all the mass excavated areas. The contractor would then have either a 1, 2, or 3-man crew, a grade checking crew rather, working off the stakes by stretching strings between the stakes. Then they would relay that information to the operators by painting marks on the ground or using hand signals. Obviously very time consuming. Today, the majority of mass excavation projects and many roadway and highway projects are constructed utilizing machine grade control technology with the use of a proposed surface model, or also known as a DTM, a digital terrain model. The main purpose for the surface model is machine grade control. However, there are a few other items that we'll mention later in the presentation that we can use this model with. The earth moving equipment used for the civil construction, roadway construction can be equipped with either GPS or UTS equipment for machine grade control. The majority of what you see and what's utilized is GPS equipment. When it comes to finished grade operations, that's when you start moving towards more of the UTS equipment. But nowadays, with the GPS being as accurate as it is, a lot of it is still done with GPS. So the main reasons for using machine grade control. You control or at least limit the amount of wasted materials such as gravel, topsoil, haul off, and import material. The efficiency of the earth moving operations, mainly no staking needed. And another reason is reduced personnel and increased safety. No need for the grade checking crew. This eliminates 2 or 3 and several trips for staking by the survey crew. No personnel is basically needed on the ground around the earth moving equipment, and the operator has no need to be getting on and off the machine. Typically they do several times during the operations when you're stretching the strings. So surface models prepared with a combination of the engineer's CAD file and the approved construction plans. It is possible to prepare the entire surface model from a vectorized PDF of the approved construction plans if there's sufficient geometry is included in the plans for establishing the site horizontally. Typically, all the layout is expected to be prepared from the CAD files, so then it's necessary to prepare the surface model using the same. And this is typically more accurate. Items used for the model preparation, you get the CAD files I mentioned, you get the engineer's base proposed CAD file with proposed elevations or proposed contours elevated, proposed utilities, and proposed feature lines and hard surfaces. The plans that we use to put this together along with the CAD file would be the obviously approved construction plans, which would include site plans, grading plans, roadway plans, profiles and alignments, drainage details, utility plans, the typical section details, and any cross sections such as for roadways. Types of surface models would be finished grade surface. This is the most common. As a matter of fact, when I prepare anything, I always start with a finished grade surface. Then you can extract out the subgrade surface. This is sometimes used for excavation, but mostly used for volume calculations. Next would be an over excavation. Would be used for such as basement walls. You got to go back so far away from the wall for safety reasons, and then typically sloping back also for safety reasons. Retaining walls, the same reason for trenching, and other sites with necessary sloping. Another thing we can use them for is utility and sewer lines. Models are prepared utilizing elevated line work. So using the CAD file, we will prepare the surface model using a series of elevated 3D polylines. These are known as break lines or feature lines. The 3D polylines are created on separate layers to represent all hard surfaces such as curbs, walks, roadways, buildings, etc. These lines are placed and elevated per the information noted in the construction plans. Surface models are prepared using various CAD-based programs rather. All use the basic concepts such as 3D polylines or feature lines. Once all the necessary 3D polylines have been created, we can prepare the finished grade surface in the same manner as any typical topographic survey. This is typically done with a survey program or a civil engineering program such as Civil 3D or Carlson. This surface can be exported in various formats for use with many types of machine grade control. Types of machine grade control are Trimble, Topcon, Leica, Carlson. There may be others out there, I'm just not familiar with them. Methods for preparation of utility flow lines. This is something that is not as common as for mass excavation. Individuals are starting to use it more and more. Same methods can be used for the preparation of utility flow lines for the construction beds of the utility trenches. You would prepare the alignment file from structure to structure along the alignment of the center line of the pipe. The 3D polyline would be created to go along the flow line of the proposed pipe to create the profile. Or you can prepare a surface for the bottom of the trench. The operator can then use functions within the machine for offsets from the alignment, the profile, or the surface. Another function for the surface model is preparing staking data. Using the 3D polylines and other information within the surface model, we can prepare our staking data. By using this information, we are preparing our stake data from the same information files that the heavy machinery is working with. This is the best way to eliminate excess wasted material. Everything and everyone is working with the same information, the plans, methods, and technology. Basically, the machinery is cutting grade to finish grade to the same accuracy that a surveyor is using on a survey rover. Meaning GPS, typically you can get it within a half an inch. There's also this is also a very efficient and accurate way to prepare the stake data.
All right, Ray, I'll take over here from on the staking data. So with the staking data, we take the line work and the surface model once Ray has created that. And the first thing we do is when we start having the interactions with the contractor or the client is, when they call in a request, we want to make sure that we are, asking the right questions and understanding, and then sometimes actually helping them understand, sequencing of what we need to do, never being your client's always right, but never disagreeing. But sometimes they may get things out of order. So we want to understand exactly what it is they're looking for. We also do another, even though it's already been through a rigorous QA/QC process, we want to do another QA/QC on the data. Then we get to where we're putting the field packet together. This is one of the big differences. I feel like we're successful here at Mazer. Is it starts with a work order. We get that prepared so it gives the crews the exact guidance, what they're going to be doing on that work order. You lay out what they're going to be doing. You also have the contact information for the clients at the site, whether it be the grading foreman or superintendent or the utility foreman or superintendent. So when the crew gets to the site, they can actually call up and say, hey, we're here from Mazer or here from wherever to provide staking. This has kind of got the list. I was given the rundown of what we're going to be doing. Do you need that order changed? Is there become a critical path here when you get on site? Then with that work order, we're also providing point maps, which is critical. And the point maps are highlighted in the areas that they're going to be working in for that day or that particular operation. Those are so critical. In my past, typically the call has come in at times. Hey, I need you to run over to Project X. The contractor needs some grading stakes, and that's it. So the success of STAKEOUT becomes with having a great field packet put together with pretty precise and concise directions to give to your field crews and send them on the way, all the time having them call back in if they've got any questions. We go to the next slide, Ray. The construction staking, the preparing from the surface model. It's just we take that data and again along with the work order and the stakeout maps, you're generating your points that the survey crew, for instance, on a parking lot or your curb, you're generating those points for what we call the fine staking operations. That they're basically at that point they're ready to truly get it down to the nitty gritty. There's typically not a lot of work to be done because the model's already put them, the surface model has already put them pretty much at their subgrade. It's just we're staking as a final kind of in the field QA/QC to make sure there's not been any missed points, or just as a final check so that the contractor can come through. If you're staking a roadway, for example, and setting their string line for their automatic curb machine and things of that nature. With the other thing is typically with staking, very few stakes are needed. Final stakeout of your settlement basins when they're converted to your final SCMs or which the final ponds. We can go to the next slide, Ray. This is a feature that I've come to really appreciate, and clients have really started have really taken this and embraced it and really appreciate it. This was shown to me. I had one of our senior crew chiefs here about 6 months ago. I was wanting to know, kind of where they were on a site staking clearing limits, and he sent me this wonderful Google Earth map, and my next phone call was right back to him and said, you've got to show me how you do that. So showed me how to do this, and it's what's really been neat about it, as you can see with the example here, the picture in the slide to the left is of a site that we're working on here in the North Carolina, Charlotte area. The red icons there are your actual clearing limit points. The green icons are your tree save areas. And we've zoomed in and take so you can actually see the point numbers. The great thing about this is you create you send a text with a link, and as long as a person has a smart device that is enabled with either Google Earth or Google Maps, the regular driving map app, you can pull this up and you can literally use your smart device and walk to the stake. It's been my experience that Google Maps in the field tends to be a little more accurate. The plus or minus discrepancies seem to be just a little bit better. The other great thing about this feature that the contractors have really embraced is when it comes to clearing limits, we can give real-time updates at the end of every day. The crew's working on clearing limits. We bring in their points, we create it and send it out to the contractor so they know, well, wow, they're around to this point here. You change the icons to green on that operation, and the ones that are left are in red. So they're really getting a daily update of real-time operations, so they know, okay, well, I'm out far enough, or they're out far enough in front of me. The clearing crew or erosion control crews can't catch us. I can call them in and get them started. You can also use this operation by, for staking manholes or storms. It has a myriad of possibilities and opportunities to provide information really in a real-time scenario back to the client. So that's something that has really taken off here, that the client and contractors are really enjoying, that we're utilizing this information. Next slide.
Okay, thank you, Brian. Let me speak a little bit more on another benefit of using surface models. When a contractor typically starts a project, during the estimating phase, they do a takeoff, and there's several programs out there to do takeoffs with. Some of those programs you're able to export out surface models with. Typically, I usually don't use those programs. Typically, I stick with the CAD-based programs, and we prepare a more detailed surface model. Once we have that, then we continue on sort of the same process as what the estimators do. We prepare a cut fill sheet of the entire project using the CAD line work. Then we prepare a cut fill sheet set with a grid pattern set across the entire site. Cut fill labels can be prepared from the original surface or from the top of the clay or rock being calculated surface after all the topsoil stripping and excess burden have been removed. Then we compare it to the proposed finished grade or the calculated subgrade surface. It varies as to which one you want to go with for different reasons. We would prepare the subgrade surface based off the typical sections of the proposed imported materials. Then we can prepare a series of reports showing the volume of the area of the cuts fills and the areas cuts of the material being used on site. We can create a series of region reports to isolate specific areas. So as you're looking at the map here on the screen, we can see a building that was cut out purposely, but around there you've got a parking lot in the very front on the south side. We've got a lot of fill just to get to basically the yard of the structure. Then off to the lower right hand side we have a big red area that's all cut. That's a detention pond. So this project was designed specifically to have no excess waste or imported material. It was basically a balanced site. Here on this screen, we can show an example of some of the reports we would put out with doing this. The top one is the topsoil volume reports. We got I mentioned earlier, one of the types of models is the over excavation model. Well, here's the volume report showing the material that needs to go back when we fill in that excavated area. the basement wall backfill, and then the subgrade volume reports. And that particular report is broken up into a bunch of different areas. That's what I typically refer to as regions. So in summary, as we discussed, we discussed the current site grading techniques, the many different types of surface modeling, many uses of the surface model, site staking, locating and tracking stake points, cut fill sheets, and volume reports. Maria, this time, is there any questions?
Hi, okay, great. Thank you, Ray and Brian. We have a few questions. This question is from Kevin. What is the typical turnaround time for modeling a site for machine control?
That varies. It can be either 1 day to 5 days, depending on the type of project. I like to think of it as if you have a big warehouse box store with minimal site detail in the parking lots, maybe just one large detention pond, not a lot of detail anywhere throughout the project. Doesn't matter what size the project is, the less detail, the quicker the model. It could be 1 acre to 40 acres, even 100 acres. It can still take just 1 day. But if you get something detailed like a large subdivision with a lot of roadways, a lot of pads, say a lot of grading sheets, basically I like to think of it as for every grading sheet we have to go through, there's an hour and a half spent of time working on the model. So those are the ones that could take up to a week.
Okay, thank you. This question is from Donna. What are the benefits of a surface model to a contractor?
The benefits of a surface model to a contractor is number one is for the machine control. You can put the model into the GPS equipment that is installed on the machines. Improves your accuracy. It's efficient for the overall operations. No men on the ground. There's your safety reason. The biggest one right there is the safety, I guess. But it does speed up the operations.
Okay, thank you. This question, I think I could pose it to Brian. This question is from Chris. What is the preferred input to start the modeling process?
The preferred input is your CAD drawing from Civil 3D or Carlson, that matter, but the CAD drawing is the preferred input. As Ray mentioned in the presentation, you can do it from other methods. It just takes a little longer. But with the CAD drawing, it speeds up that process.
Okay, thank you. And one more final question is from Sean. What kind of cost savings could he expect with this 3D modeling as opposed to a traditional layout?
Early on, or rather years ago, I was always told this would save the cost of about 20 to 30% of the overall excavation process. That's combined with material savings, reduced personnel on site, and the efficiency of the overall operations, mainly because no operators really need to get off the machines other than for just checking things periodically, but for the most part, they shouldn't have to get off the machines.
Okay, thank you. This actually will conclude the Q&A session. So I will hand it back over to you, or Brian or Ray. Do you have any final remarks? Or just maybe leave them with your contact and Mazer's contact information?
Yeah, the contact information shown on the screen. Please feel free to reach out to us if you have any questions or need our service for anything. Thank you.
And I'd like to echo that, what Ray just said. I'd also like to thank everybody. Know that in today's time and everything that we've got going on, I just appreciate everybody's willingness to log in and spend 30 minutes with us. We greatly appreciate that, and we look forward to the possibility of partnering or serving with you in any aspect we can. Thank you so much.